All right. So a car of mass 800 kilograms pulls a trailer of mass 200 kilograms along a straight horizontal road using a light tow bar which is parallel to the road. Horizontal resistances to motion of the car and the trailer have magnitudes 400 newtons and 200 newtons respectively. The engine of the car produces a constant horizontal driving force of the car of magnitude 1200 newtons. That's a lot of information. Okay, so we've got a car. And it's got mass 800 kgs. And it's pulling a trailer yep, that's 200 kgs. And then the horizontal resistances of the car and the trailer. So car comes first and 400 comes first. So the car's resistance is 400 newtons. The trailer's resistance is 200 newtons. And then you've got the tow bar where there's a tension, and you've got the driving force on the car. Okay, so the driving force of the causing the car to go forwards is 1200 newtons. And the last thing that we need is the tension. Now, the tension is kind of going both ways. So thinking about this logically, this trailer here isn't doing anything to help the movement. It's just dead weight.
Yeah.
So the only reason that trailer is moving is because it's attached to that tow bar. And if the overall movement is to the right, then the tension on the from the tow bar, acting on the trailer is going this way.
Okay.
And that's tension. But the tension's also acting in the opposite way, because if you think about it, the car is moving, the car is pulling dead weight. If the car had the same driving force and did not have that tow bar to pull along with it, it would be able to go faster.
Yeah.
So something is pulling it back. So you've got the same tension, it's also pulling that car back.
Okay.
So all of those are the forces that are needed to be considered.
Got it.
So cool. Then it says find the acceleration of the car and the trailer. So we can do this in I like this way. So to work out the acceleration, it's actually quite simple. What we can do is consider the whole system. So by considering the whole system, we consider all the forces and we consider both particles as if it were one.
Okay.
So for part A, we're going to consider everything, whole system. Okay. So in the whole system, we're going to use F equals ma. Now, just to test you, what does F stand for in F equals ma?
Resultant force.
Yes, resultant force, not just force. Cool. So now the resultant force is the sum of all the forces acting on the particles in this stage, it's the whole system. And also the direction matters. So I'm going to say that going right is positive and going left is negative. It doesn't really matter which way, as long as you pick a way and you're consistent with that way. Now, the forces going to the right are the 1200 newtons and the red T. So I'm going to say 1200 or 1200 plus T. The other forces are all going to the left, so they're going to be negative. So we've got minus T, minus 400, minus 200. Now, all of that is your F. Those are all the forces. And that is equal to mass. And for this case, the system, what is the mass of the system?
1,000 kilograms.
That's it, 1,000 kilograms, because it's the 200 kgs plus the 800. And all of that is multiplied by acceleration.
Right.
Now, this is the only equation that we need. Some people might think, but there's t as well. However, the t's will cancel.
Right.
So, in actual fact, the t's cancel, and you've just got 1,200 minus 400 minus 200, which just leaves you with 600.
Right.
And that is equal to 1,000A. So therefore, dividing both sides by 1,000 gives you, 0.6
Yeah.
is equal to A. And that's 0.6 meters per second squared. That's part A. And then with part B, now, so with part A, the thinking was, okay, let's use the whole system. But with part B, so that we get some sort of equation with tension involved, we'd look at just one of the particles and look at all the forces acting on it. So we have choices. We could either look at the car or we could look at the trailer. What would you prefer to look at?
Let's do the trailer.
Okay, why did you pick the trailer out of interest?
Because 200 is less than 800.
Because 200 is less than 800. Fair enough.
Yeah.
Fair enough. Fair enough. I would have said the trailer because
Okay.
if you look at the forces acting on the trailer, there are only two forces acting on the trailer.
Yeah.
Whereas on the car, you've got three forces acting on it.
Okay.
You got the driving force, you got the resistance to motion of 400, and you've got the green tension. Whereas the trailer is only the tension in 200. But 200 being less than 800, that's fine too. Cool, okay, so looking at trailer. So if we look at the trailer, again, maintaining this idea that going to the right is positive and going to the left is negative, the forces that are acting on the trailer, well, the forces acting to the right are T. It's the only force, actually. And the force acting to the left is 200. So T minus 200 is equal to MA. So we're using F equals MA. So that's the force, the resultant force. Nearly tripped up on my own little thing. The resultant force is equal to mass. What's the mass in this case?
200 kilograms.
Yes, because we're only looking at the trailer. So T minus 200, and the 200 is because of this 200, not to be confused with the mass, is equal to 200 kg multiplied by acceleration. And we know the acceleration is 0.6. Because from part A, we worked out the acceleration of the whole system, because the car and the trailer are going to accelerate at the same rate. So T minus 200 is equal to 200 times 0.6. Therefore, T is equal to 200 plus 200 times 0.6.
Okay.
And what's that going to be? I think 320?
Yeah.
And specifically 320 newtons.
Okay.
Does going through this help us understand, first of all, F equals ma, the significance of
Yes.
calling F resultant force, and also the significance of the diagram and how to deal with connected particles? Awesome.
Yeah, it does.
Nice.